Okay, so here we go. This is where we ended off yesterday. What we're going to do is we're going to sketch the angle in standard position. So how do we sketch in the standard position? The very first thing I want you to do is I want you to go ahead and put your axis, and here is going to be your initial side of your angle. Would we all agree with that? Now, what we have going on here is we basically have this circle. You see the circle? Whenever you do this circle, I need your brain to think, okay, well, that is the denominator is 3. That means I'm going to have 3 slices of pizza on the top, and I'm going to have 3 slices of pizza on the bottom to create my full circle. Do you all understand that? So this is going to be 3 pi over 3. Why? Because that's equivalent to pi. Does that make sense? Then, if I take the bottom, I'm going to have 6 pi over 3, meaning I am literally going to divide this into 6 slices, okay? So if I do that, I'm going to have 1, 2, 3, 4, 5, 6. Can you see my 6 slices? Yes. It's not very nice. It doesn't look very pretty. 1 slice, 2 slice, 3 slice, 4 slice, 5 slice, 6 slice. Do you see it? Yeah, I can't draw it very well. I'm going to be really honest. So you're going to go here and here, here and here. So, and you're also going to keep that one right there. So here's going to be the 1 slice. Here's another slice, here's another slice, here's another slice, another slice, another slice. You see it? I'm a terrible drawer. You have to go with me on this. I obviously am bad at drawing, but it's okay. Because what I need your brain to get is I have 3 slices on the top and 3 slices on the bottom. How many total slices does my problem say I need to have? 4. So I am literally going to start right here, and I'm going to go 1 slice, 2 slice, 3 slice, 4 slice. And that's going to bring me all the way over here. So this is going to be 4 pi over 3. Yes? It's going to be 4 pi over 3. Now, same exact thing over here. I'm going to go ahead and look at my denominator, and that's going to be a 4. That means that this is going to be a negative 4 pi over 4. Why is it negative? Because whenever I did the first example, 4 pi over 3, I was opening counterclockwise. And this example, I'm opening clockwise. So I'm going to have 4 slices in the bottom that I'm going to use first, and now I'm going to have 4 slices on the top that I'm going to use second. Do you understand that? So what I want your brain to do is to divide this up into 4 equal slices. Do we see the 8 slices total now? Yes or no? Do we all see the 8 equal slices? Okay, now I am going to start right here, and I'm going to open, and I'm going to go 1, 2, 3, 4, 5, 6, 7. Why 7? Because my problem says I need to do negative 7 pi over 4. So I'm going to go down clockwise from my standard position, with the initial side being on the positive x-axis, and I'm going to simply rotate clockwise 7 sections of that circle. Do we all understand that, yes or no? We good? So I will end right here, measuring the outside. We good? Okay, let's do it again. This is exactly the same concept, except for now we're talking about quadrants. When we talk about quadrants, your quadrants are 1, 2, 3, and 4. Do we all see that, yay or nay? Now, what your goal is to figure out which quadrant these land in. So we're going to do this exactly the same way that we did before. So I'm going to look at my denominator, and that's going to be 5. So this is going to be 5 pi over 5 over here. So 5 slices of pizza on the top because it's positive angle. And then I'm going to have 5 more slices on the bottom to give me 10 pi over 5 over here. How many slices of this pizza do I want? What's it say?
1.
1. So I only want 1 slice of this pie. So what quadrant am I in?
1.
I'm in quadrant 1. Done. Does that make sense? Okay. Go to the next one. Same exact concept. I'm going to go ahead. I'm going to look at my denominator, and I also see that it's negative. So I'm going to have negative 9 pi over 9 right here, meaning I have, because it's negative, I'm looking at the bottom quadrants first. So that's going to give me 9 equal parts at the bottom. Then going to have 9 more equal parts on the top to give me negative 18 pi over 9. Yes? And how many parts do I want? 11. So how many do I have in the bottom currently?
9.
I have all 9 in the bottom, then how many more do I want from the top? I need 2 more. So where's that going to put me at? Quadrant 2. Do we understand that? Yes or no? 7 pi over 5. 7 pi over 5. Immediately look at the denominator. The denominator is a 5. It is a positive angle. So that means I'm going to have a 5 pi over 5 here and a 10 pi over 5 over here. Does everybody see that? This is a positive angle, so that means I'm going counterclockwise. I want how many total slices of this? 7. So I have 5 slices on the top, so I'm going to go all the way around the top, and then how many more slices do I need? 2 more. So what quadrant am I going to be in now? Quadrant 3. Do we understand that? Yes or no? And the last one is a decimal. So that means we have to transform all of our lovely radian measures into a decimal radian. So this is going to be pi, which is the same thing as 3.14. This is going to be 2 pi, which is the same thing as 6.28. This is going to be pi over 2, which is the same thing as 1.57. And down here is going to be 3 pi over 2, which is the same thing as 4.71. So can anybody tell me where 3.5 would be at? If I'm in standard position, I'm going to go positive. I'm going to go up into the clockwise, into the counterclockwise position. I'm going to go past pi, and I'm going to land in quadrant 3 for 3.5. Do we all understand that? Yes or no? We good? That's how you're going to do problems 5 through 8 on tonight's homework. You have to determine what quadrant they're in. Any questions over what I just did up there? Does that make sense? May I move on? Okay, next, it says to sketch and determine the quadrant in which the angle lies. What did I give you this time? Degrees. Well, you guys know degrees pretty darn well, don't you? Degrees, this is going to be 0 degrees, 90 degrees, 180 degrees, 270 degrees to give you 360 degrees. Where's 150 at?
Between 90 and 180.
It's between 90 and 180, which is going to be right around in there, so therefore we're in quadrant 2. Does that make sense? The next one is degrees, minutes, and seconds. Degrees, minutes, and seconds. Degrees, minutes, and seconds. So if I am a pilot, I'm going to go 336 degrees north. You with me? Or actually south. And then I'm going to travel for another 30 minutes. And then so many seconds. The dash mark means minutes. If there's 2 dashes, that means it's seconds. Do we all understand that? Same exact concept. This is 0, 90. Sorry. 0, negative 90, negative 180, negative 270, negative 360. Do you see how the negative 90 is going to be switching? Instead of being at the top, it's going to be at the bottom. Why? Because it's a negative angle. I'm opening the opposite direction. We all understand that. So where is negative 336 degrees and 30 minutes going to be at? It is going to go all the way over here to quadrant 1, and that is correct. So I'm a quadrant 1 angle. Why? Because it's a negative angle. Y'all good? It's a negative angle. Now where's 282 degrees? Anybody?
Quadrant 4.
It is going to be in quadrant 4 because this is 360 degrees. This is 270. So you know you are going to be in quadrant 4. Do we understand how to do that? That is how you're going to do problems 27 through 30 and 31 through 34. Can we do it? You okay, Zane? You sure? Okay. Next, coterminal angles. Now, the way I describe this is I want you to envision your car. Okay? You're in your car, and you are driving. The wheel does not change, does it? The wheel just keeps on going. A revolution, another revolution, another revolution, another revolution. You with me? The coterminal angle is exactly that. It's kind of like any revolutions around that circle. Do you all understand that? You can have a corkscrew angle that goes around 5 times. Does that make sense? You can have a corkscrew angle that goes around 4 times with a negative angle. Yes? Same exact concept. So how do we go about this? The way you're going to do this is you're going to add 2 pi and subtract 2 pi for given radians. If you're given degrees, you're going to add 360 and subtract 360. You all understand that? So you get a positive angle or you get a negative angle. Yes? So this says to find a positive and negative coterminal angle to pi over 5. So I'm going to take pi over 5 and I'm going to simply add 2 pi to it. You with me? So if I add 2 pi, you are simply going to put this over 1, and you're going to multiply the 2 and the 5 together to get a common denominator. So that's pi over 5 plus 10 pi over 5 to give you, what is the angle? What's 1 pi plus 10 pi?
11 pi.
11 pi. We good? Now that's my positive coterminal angle. How do I find my negative coterminal angle? My negative coterminal angle, I'm going to do exactly the same procedure, but instead of adding, I'm going to subtract 2 pi. So pi over 5 minus 10 pi over 5 is going to give you what value? Negative 9 pi over 5. So my 2 coterminal angles, or 2 pi over 5, is going to be positive 11 pi over 5 and negative 9 pi over 5. Do we understand that, yes or no? Same exact procedure, except for this time I'm going to give it to you in degrees. Does everybody have their calculator with them? So if I have 76 degrees, and I want to find the coterminal that's positive, I'm going to add 360 degrees. So what is 76 plus 360 degrees? 400 and what? Yep. 436 degrees. Do we all understand that? Now that's my positive angle. Now how do I find my negative angle? 76 degrees minus 360 degrees. And what is that going to give you? Negative 284 degrees. Do we understand that, yes or no? Would we like to do another radian problem? Would you like to do another radian problem, or are you good? The bottom one, pi over 6. You want to do another? Okay. So same exact thing, we're going to take pi over 6. I'm going to add 2 pi to it. If I'm doing negative, I'm going to take pi over 6. I'm going to subtract 2 pi from it. Do you all understand that? So how do we get a common denominator? I took the 6 times the 2. 6 times 2 is going to give me a 12 pi over 6. What is 1 pi plus 12 pi? Yep. Over here, I'm going to have pi over 6 minus 12 pi over 6. So what is 1 pi minus 12 pi? Yep. That is how you're going to do problems 13 through 14, I think. I think it's those numbers. Are we good on that? Next, equivalence. Super, super important, okay? 360 degrees. 360 degrees is equal to how many radians? 2 what? 2 pi. Now, if you see an r to the r power, that just means that it is a radian. Do we all understand that? If you ever see an r as an exponent on a pi, that just means it's a radian measure. What decimal equivalent is that? What's 2 times pi? 6.28. Divide 360 by 2, and what does that give you? 180 degrees is equal to what in radians? Pi. And what is the decimal equivalent of pi? Take 180 degrees and divide it by 2. What's that give you? What is the radian measurement of that? Pi over 2. And what is that decimal equivalent? 10.57. Then, if you are going to do 270 degrees, What radian equivalent is that equal to? 3 pi radians over 2, which is going to be equal to 4.71. You have to memorize those. That is 12 points on your unit circle test. You gotta understand that. It's extremely helpful for whenever you need to get a quadrant. Now I'm going to skip over to the last slide for a minute, just so that you guys can see something. This is the last slide that I wanted you to talk about. Those are exactly the same thing. Okay? This slide right here says that all the angles between 0 and 90 are in quadrant 1. Radian measures are those are from 0 to pi over 2, and decimal are going to be from 0 to 1.57. If you are in quadrant 2, those are going to be all the degree angles between 90 and 180, or all the radian measures between pi over 2 and pi, or all the decimal radians between 1.57 and 3.14. Does that make sense? If you're in quadrant 3, those angles are going to be from 180 to 270, or pi to 3 pi over 2, or 3.14 to 4.71. And in quadrant 4, that's going to be from 270 to 360, which is 3 pi over 2 pi, or 4.71 to 6.28. Do you understand that? That's just helping you see it in all the different ways of degree, radian, and decimal gradient. Do we all understand that? Okay, let's come back up here and talk about complements and supplements. Back in geometry, you heard the word complement. What does a complement mean? In geometry and math terms? Complementary. If two angles are complementary, what does that mean? Nope. What's complementary mean? Complementary is when you have two angles that add to give you 90 degrees. Supplementary is when you have two angles that add to give you 80 degrees. Okay? Now, the directions say find the complementary and supplementary angle if it exists to pi over 3. How would I say if it exists? When would you not have a complementary or a supplementary angle? When would it not add up to 90? For example, I give you 105 degrees. What's the complement to 105 degrees? Do I have a complement to 105 degrees? Why? It's bigger than 90 degrees. So if you have an angle that is larger than 90 degrees or pi over 2, then you will not have a complement. So write that down. If your angle is larger than pi over 2 or 90 degrees, it will not have a complement. It will only have a supplement. If your angle is larger than 180, it won't have a complement or a supplement, will it? Do we all understand that, yes or no? We good? Okay, find the complementary to pi over 3. Complementary is 90 degrees minus your angle, which is pi over 3. We are not in the same measurement here. So what is the radian measure to 90 degrees? What is 90 degrees equal to in radian measure? Pi over 2. So this is going to be pi over 2 minus pi over 3. I need to get a common denominator. What's my common denominator between 2 and 3? 6. So both of these need to turn into a 6. So 2 times what gives you 6? That's a 3, so that's 3 pi over 6. 3 times 2 is going to give me 6, that's a 2 pi over 6. So what is 3 pi take away 2 pi? Pi over 6. Pi over 6 is your complementary angle. Do we all understand that? Now what about my supplementary angle? That is going to be 180 degrees minus pi over 3. What is 180 degrees in radian mode?
Pi.
Yep. So that's going to be pi minus pi over 3. Can I go ahead and change this pi to be 3 pi over 3 because that's the denominator than the other one? So what is 3 pi minus 1 pi? So this is going to be 2 pi over 3 is going to be my supplementary. Do we understand how I got those numbers? Yes or no? We good? Okay, next. We're only going to do the top one. What is the supplement to 75 degrees, or the complement to 75 degrees? The 75 larger than 90? No, so I'm going to take 90 minus 75. And what is that measurement? They're both the same measurement system. So what is 90 degrees minus 75 degrees? So the complement angle is going to be 15 degrees. How do I find the supplement? You're going to take 180, which is 180 degrees minus 75 degrees, and that's going to give you 105 degrees. And we have already done this one down here, which is pi over 3. And that brings us to that. And tonight's homework is going to be 2 through 34 even. This is on page 255. So the rest of the period is yours to get busy on homework, yes?